Howdy Pre-Calculus. I've got a new video for you. It's the third lesson on 1.4. We're basically dealing with roots and fractional exponents. It's kind of a mixed bag of concepts, so try to keep up. The first two situations, we have square roots. Here in the first one, here in the second one. To undo a square root, to make it leave the equation, we really need to isolate it on one side of the equation and then do the opposite of the root being taken. So I'm going to isolate it first, subtract 3 from both sides. All right. And then this is technically the square root of 3x plus 1. To undo a square root, you take a value to the 2 power. So you square a function to undo the square root. This leaves you with 3x plus 1 and a polynomial that needs to be expanded. Error alert, a lot of people will try to take x minus 3 squared and quickly call it x squared minus 9. That's not true, because x minus 3 squared is x minus 3 times x minus 3. That needs to be expanded like a polynomial. So you take x times x, you take x times negative 3, which is the same thing here. So it's like you're doubling negative 3. Right? Negative 3x minus 3x is negative 6x plus 9. So try not to get trapped in that error because it's so painful. Every time a math teacher sees it, it is just painful. All right. Now that we've got a polynomial on the right-hand side and just some other stuff on the left-hand side, let's move everything together. So subtract 3x, subtract 1, and you get 0 is equal to x squared minus 9x plus 8. Looks like a quadratic equation. Do a quick look over and see if it's factorable. This one is. Negative 8 times negative 1 is 8. Negative 8 plus negative 1 is negative 9x in the middle. So you got factors of negative 8 and negative 1. This is a shortcut you can do if the leading coefficient of the polynomial is 1. If it's 1, you can find out those two special numbers and just plop them in with x in the equation. So once we get there, we're going to solve these equations. X minus 8 equals 0, x minus 1 equals 0. And you're left with x equals 8 and x equals 1. Now here's an interesting thing that happens. Whenever you square an equation, you're actually fundamentally changing everything about it, which means that these answers are vulnerable. They're vulnerable to potentially being extraneous. I don't know if you guys have heard that word before, but let me just explain that a little bit. The square root of 3x plus 1 kind of looks like this. I'm not expecting you guys to know that that's exactly how that function looks. What I'm saying is the square root of 3x plus 1 can't go below the x-axis. All right? That's kind of an estimate of what it looks like. X minus 3, I would expect you guys as juniors and seniors to be able to graph a linear equation. The starting point is negative 3. The slope, rise over run, is 1 over 1. So you go up 1, right 1, up 1, right 1, and so on and so forth. Okay, now what was the point of me graphing that? The point of me graphing that is that the left-hand side of this equation equals the right-hand side of this equation one time, which means it has one solution. There's two solutions down here, which means one of them is extraneous. It basically came out of the excitement of squaring both sides. We created a totally new polynomial. We created something that looks like this. when really in reality, it looked like this. So one of these actually isn't a solution. You can check by plugging it into the original statement. Plug 8 in right here. So this is our answer check. Is 3 plus the square root of 3 times 8 plus 1. Does that equal 8? That's 25. 3 plus 5 is 8. That one checks out. So this one probably doesn't work. Prove it. 3 plus the square root of 3 times 1 plus 1. Does that equal 1? Never, because 3 plus a number that must be positive will never equal 1. But I'll finish it out. This is root 4. Yeah. 3 plus 2 is equal to 5, not 1. So that answer doesn't work. Again, I'd write this down if you're not totally familiar with it. That's an extraneous solution. And it happens sometimes when you square both sides. That's not the only time it happens, but for purposes of today, be checking it out if you do something like that. Second one. All right, we can do the same thing. I've actually got 2 ways to do this. I'll show you both ways. Sort of leading from that first example, if we get this root by itself and just square both sides, we should be able to kind of move forward with the same calculations. So x plus 2 equals 3 root x. I could divide by 3, but let's just avoid the fractions and actually square this quantity with 3 in it already. So we can square that, square this, rewrite this twice, expand the polynomial. This would be 3 times 3, 9, root x times root x, x. X squared, 2x plus 2x, and then 4. So then I can subtract 9x from both sides. That'd be negative 5x. Oh, good! We've got another factorable polynomial. Negative 4 times negative 4 is the same as negative 4 plus, I'm sorry, I said that totally wrong. Starting over again. Negative 4 times negative 1 is 4. Negative 4 plus negative 1 is negative 5. All right. That. So then this will give you the x equals 4 solution. This will give you the x equals 1 solution. We squared both sides. You might want to check some things out at the very beginning of that equation because it didn't work out well for the last example. So plug in 4. Does 4 equal 3 root 4 minus 2? Does 4 equal 3 root 4 minus 2? Well, this would be 3 times 2, which is 6. That checks out. Try it with 1. Does 1 equal 3 root 1 minus 2? Hey, you can't see that. I'm sorry. There we go. Okay, so what does this teach us? It teaches us... Sorry, guys. I'm really struggling on this video, but I'm not going to restart it because it's been a long day. So both of these solutions are good. They both check out. So you don't always have to have an extraneous solution every time you square both sides. And you know what? I think I'm going to just hold off on that extra explanation for this one. There is another way, but it's kind of complicated, so let's just leave it. All right. I got a lot to say about the number 64. All right. X squared equals 64. I wanted to compare that first to x cubed equals 64. And it's a pretty basic move. You square root both sides, x equals plus or minus 8 in this situation, over here you cube root something, x is going to equal not a plus or minus, okay, so 4 times 4 times 4 is equal to 64. It's not plus or minus, like a negative 4 times negative 4 times negative 4 is negative 64. So the cube root of that is just positive 4, not plus or minus. I wanted to keep this train moving. Like, what if we had x to the 4th equals 64? All right, so what happens when you 4th root something? Or did I mean something else? I think I might have meant something else. That's okay. The 4th root of 64 would be, well, 64 is equal to 2 times 32, 2 times 16, 2 times 8, 2 times 4, and 2 times 2. There's one set of quadruplets in there that can come out. Of 2's with 2 left over right here. Now the question is, do I put a plus or minus in front of this whole thing? And the answer is yes, you do put a plus or minus. Here's why. The even roots are the ones that create the potential for a plus or a minus. So just keep that straight. Odd roots, there's no need to take into consideration positive or negative, like this. Okay? Also keep in mind that the cube root of negative 64 is negative 4. So it's like you can be one or the other when you're an odd root, and then when you're an even root, you have to force the plus or minus for both times. All right. Yeah, I'm going to talk about these 3 fractional exponents, and hopefully it'll piece together from what we've been talking about. So let's say now that you're talking about x to the 2/3 is equal to 64. There's 2 ways to think about this. One, this is this x squared. The cube root of x squared is equal to 64. If it's the cube root of x squared equals 64, then your first move is to undo the root. So cube it. I don't have 64 cubed memorized. $262,144. It's a big number. And then we square root that, which creates the plus or minus because we took an even root of it. The square root of that is 512. So that's one way in which to approach fractional exponents. However, it's not the only way. If you recall, the properties of exponents state that you can take something to a power that, like any power you want, just as long as you do it to both sides. So what we want to do is we want to neutralize this 2/3 and make it a 1 somehow. So what times 2/3 gives you 1? 3/2, just multiplied by its reciprocal. Now you get 64 to the 3/2. And if you want to think about this in the context without a calculator, think about 3/2 as 1 and 1/2. So this is like 64 and 1 1/2. That's the same as 64 to the 1 times 64 to the 1/2. When you think about that, Actually, hold on. I'm going to stop the video. We'll continue this on the next one.